He's coming from beautiful Toronto in Canada today. He is a global cross-industry expert on artificial intelligence. He has spoken multiple times in our conference, and we are always enriched by his perspectives. Talking about Bill Wong, he's here with us. Bill is an AI and data analytics practice leader at Dell Technologies, responsible for supporting banks and insurance companies, fintech, cryptocurrency, and blockchain firms. He has been directly involved with a number of public and private institutions to help them define their AI strategy and deploy a platform to accelerate business insights. He publishes a quarterly AI newsletter, a contributing author with researchers from a Canadian university for a paper on how deep learning algorithms can accelerate the drug discovery process, and has also written numerous books and white papers on the top of analytics and best practices. Bill, it's always a masterclass when you talk about artificial intelligence. You know the difference between hype and reality, and you do a wonderful job of communicating that to the rest of us. Thank you for being here and sharing your expertise today.
Well, thank you, Jose. Thanks for the warm introduction. Hi, folks, from Toronto, Canada. As you can see in my first slide there, that's Toronto in the evening. And hope we can all see each other soon in person. So I'll be broadcasting from Toronto, and today's topic will be digital transformation financial services through analytics, advanced analytics. I'll focus quite a bit on AI. I'll take you through some current trends and directions that we're seeing in the industry, and then talk about the ecosystem that people are building, especially in financial services, to deliver their AI initiatives. And then we're seeing a lot of firms tackle the multi-cloud world with AI, and we'll talk about some of the best practices there. So just a little plug about Canada. If you haven't been up here, Canada's well known in the AI world, although we have kind of a low-key profile, as we are typically out there in the world. But when it comes to AI, you see the ACM Turing Awards there. Jeffrey Hinton, Yoshua Bengio, Jan LeCun, very prominent AI people. If you talk to the CEO of NVIDIA, he will say that the big boom, or what he calls the big bang of AI that sparked this growth and interest of recent years really occurred in Canada through the ImageNet contest 2012, where the researchers there, led under Jeffrey Hinton, for the first time use neural networks, deep learning algorithms on a GPU platform and just blew away the competition on image classification. So that helped spawn this huge industry that we're in right now. We'll talk about where we're at. Now, regards to digital transformation, I think everybody will acknowledge here on the left of the slide here that certainly the pandemic has accelerated a lot of initiatives. And on the right here, these are some of the top initiatives. Not surprising, security is always the #1 thing I see companies investing in. And 2 and 3, usually, while it's not on this one, is typically cloud initiatives and AI. And quite often I see AI exceed cloud initiatives. In this survey that we did last year across 4,000 C-level executives, the use of data in completely new ways made it to the top 5 here. Now, some of the barriers that people highlighted in their digital transformation initiatives: data privacy, always a big concern. Lack of budget and resources. I see that often as sometimes leaders not understanding the benefits of driving these initiatives, especially in AI. Still kind of new for some of the execs out there. And then the last one here is the ability to produce insights, and we'll take you through some of those challenges and the best practices. Now, before we dive into AI, I had the opportunity to speak at another one of these conferences that Jose was leading, and talked about business process management, robotic process automation, and AI. And you can think of this as a continuum of automation. Now, the first two, BPM and RPA, are really process-centric. And RPA, I see a lot of financial institutions. It's kind of the low-hanging fruit. You want to automate repetitive tasks, while BPM, not as perhaps easy to find, but certainly big gains there as you orchestrate people, process, and data. Now, when we talk about AI, and it does automate things, and what it's trying to do is simulate human decision-making. Now, unlike RPA and BPM, this is very data-centric, and data is a critical success factor, critical input here and output for AI to function properly. And I guess one last word about here, what I'm starting to see now in a lot of financial service firms is problems are getting more complex, tasks are more complex, and you're seeing an integration of these tasks. So integrating RPA with AI, where RPA may call AI to do a particular task. Same with BPM. So that is interesting and challenging, the integration work. This is the Gartner hype cycle that is put out every year, and I believe this came out just less than a month ago, so hot off the press. And I was taking a look at the technologies you see on the top half of your screen here, and I pulled out on the right here all the ones that are AI related, and about maybe a quarter of them are all AI related. And there are other hype cycles where AI is quite dominant. And if you were to categorize all these emerging technologies here, you could probably put them in kind of three buckets or themes here that you see on the bottom here: engineering trust, accelerated growth, and sculpting change. So from an AI perspective, the engineering trust is to try to introduce technologies that will make things more secure and scalable, things like a data platform or data fabric. Accelerating growth are those technologies they believe that will contribute to an organization's business growth. So if I take an example here, like industry cloud, you're starting to see some of the vendors introduce a cloud by vertical. So a cloud specifically tuned for, let's say, healthcare. And in healthcare is an industry that is quickly adopting AI. And then on the right there, what they call sculpting change is really trying to make AI more flexible. The challenge with AI is it's totally dependent on the data that you put in it. And it's not smart about the environment. So very complex things like weather or climate, things that you would think would be obvious when doing simulations, is not so obvious to an AI model. It only knows the world from the data you give it. So we're trying to build models that take in consideration the environment. So for instance, I've worked with a number of firms where physics-augmented, physics-informed AI, so that it knows that gravity exists, that things fall, that those kind of things that we take for granted as humans are things that they're trying to build, that kind of general intelligence into future AI programs. Now, getting back to where the rubber meets the road in financial services, I've taken the liberty of identifying some of the popular retail banking use cases. And customer examples there, these are well-known banks here, but really everybody's doing this. And I would say that customer engagement is probably the number one, at least that I've seen in Canada, the US, where if you're in retail banking, that's where a bulk of the research, the implementations are being focused at. Operations, while still a focus area, it's one of probably the easiest ones to cost justify. This is where we see technologies like RPA being integrated with AI to deliver that. And then also risk and compliance, very important piece of benefits that financial firms can get by using AI to detect fraud. This is an example of a customer that my firm has had experience working with, Mastercard. And I share the story here because in one of the presentations that I delivered pre-pandemic in person, I had a Mastercard holder in the audience there. And he said, related a kind of a funny experience where he used his MasterCard to buy some food, and just before a trip, and he was going from Ottawa to Montreal. It's about a 4 or 5 hour drive. And then he hopped in his car, and then he stopped midway, and most people will stop midway to fill up with gas. And as he filled up with gas and went to the attendant rejected his card. And he said, why? and so he called the credit card company, and he said, listen, I just used this 2 hours ago, and now you're saying, you're rejecting me for gas. And the person at Mastercard said, well, yes, it's true. I do have a record of buying some snacks in Ottawa, but technically it's really impossible that you're at the midway point to Montreal. Yeah, and it's only like in the next 90 minutes. And he kind of laughed and goes, okay, you got me. I was speeding. I shouldn't be doing that. And no problems about the false positive here. So those algorithms are being built into all the payment providers. So these companies here are well-known tech companies. You probably may not recognize that symbol on the bottom there. And I asked you, what do they all have in common outside of being pretty ubiquitous type brands? They are all getting into the AI chip business. And when we take a look at chips, or what we call AI accelerators, these are chip technologies that we use to power AI models. On the far left, CPUs, well known and dominated by Intel and AMD. The GPU processor or chip introduces a vast amount of capability to do parallel operations. That's kind of the key differentiator between a GPU and a CPU. So if you want to do like high-powered graphics, to do that, you need parallel processing of a number of vectors. And the best way to do that is to do that in parallel. So NVIDIA has made quite a name for itself there, and is really the dominant AI provider for GPU-based servers. Field programmable gate arrays. So this is kind of firmware that you can code, a little more flexibility as we move toward the right. I see these in kind of niche areas like finance and manufacturing, and Xilinx and Intel are big providers there. And then finally, on the far right here, ASIC, or application-specific integrated circuits. You see a lot of players coming here. That's where all the startup players are coming into. These are chips that are specially designed and to perform a particular task. So remember the cryptocurrency market, those chips, they could only do that. And so all the IoT devices that you see out there, they're going to build intelligence into a very small, inexpensive chip. So the good thing about it is these are inexpensive, less power, highly optimized, great performance on the kind of the weighing factor against it, that's all it can do. That's all it's been designed to do. So so let me correct. So as you move toward the left, you get to more generalized chips. So Xilinx, Intel, while you can code firmware, not so friendly, not the easiest thing to do. GPUs, a little more flexible there. Great ecosystem, but the most flexible you have is the Intel AMD. However, as you go toward the right, you get better performance. So there's a trade-off there. So I have the screen here showing GPUs, CPUs, and financial firms are all building big GPU-driven ecosystems. So what I thought I would do is, I went to my customer base to take a look at what they're all building. Some people are getting low-power GPUs for the edge on the far left. And as you move toward the right, these are things that have been well used, well understood in data centers today, but it's kind of new for GPU-based computing. So VDI, or virtual desktops, and then GPU virtualization. So this is still something relatively new to folks like NVIDIA, but they're getting into it in a big way now. Data analytics is kind of still a new area, but more and more of the software out there is being rewritten, like Spark, to be optimized to run on GPUs. AI is really kind of the sweet spot for GPUs today, but as you can see, there's this whole spectrum. So AI, most of the focus is there, continues to be. And then on the right, especially in financial services, we see some of the leading edge financial firms using GPUs for simulations, Monte Carlo analysis, research, and media entertainment, not surprisingly, continue to use this technology. Now, my friends at NVIDIA provided me the results of a recent survey they did a couple months ago. Not surprisingly, AI is very important in financial services, and many are citing that it's contributing to revenue growth. The interesting thing that I found, and just kind of reaffirms what we're seeing out there, is the use cases. So for fintechs and investment firms, what we're seeing is algorithmic trading. Talk a little bit more about that, fraud detection, portfolio optimization. So replacing humans or augmenting humans, actually, is probably the better term to use. For financial services, such as insurance companies and banks, fraud detection, big, but the number one use case still I see out there is the sales and marketing optimization, the customer 360. And recommender systems. Every time I go to my bank, they always say, do you know that you don't have one of our credit cards? And that's probably not AI doing that, probably a simple rule-based thing, but yes, many recommender systems out there. Now, when they ask these financial services subject matter experts and executives, and this is a worldwide survey that they did, they cited that there's still too few data scientists, and I guess I would have to agree with that. I'm seeing that. The technology infrastructure is still challenging, and then the lack of data. And I'll qualify that. Financial services has tons of data. The struggle and challenges is the right kind of data that they need to make these decisions. Now, on the bottom half of the screen, what you see is kind of the things that are the big benefits that are driving AI. And if you take a look at fintech and investment firms, why they want this AI platform is to build a better prediction model. You get the two high bars there. But if in retail banking, the benefit that they're really driving, number one is on the far right there. That gray bar is operational efficiency. So despite customer 360 still being dominant, the biggest benefit they've seen is doing things faster, better, cheaper. Now, getting back to algorithmic trading, here's a little history of some of the algorithms that were used over time. So in the 80s, very simple rule-based. In the 90s, more data, statistical analysis, time series analysis. Then we get to 2000s, we started using much more complicated algorithms, data science algorithms, and then past 2012 using deep learning algorithms now. And again, the financial service industry is probably one of the leading industries when it comes to using analytics overall. And what we're seeing is, again, as I said before, on integration of automation, where you see RPA and AI being used together. What you're starting to see now is also like high-end simulation workloads and AI, a data pipeline being created. So it's not just, oh, AI will solve my problem, or doing the simulation I'll get my risk analysis. They're combining these algorithms together. So it's very interesting, very complex things to do, and the banks have the initiative and the funding to do these kind of things. So how that's impacting the industry is that we're seeing this integration of high-end HPC analytics with AI. And the slide chart on your left-hand side is showing that this is a growing market. On the right-hand side, if you talk to the technology people, they're struggling a little bit with this. If you've worked in simulation environments of HPC environments, this typically has come from academia type research. Tools like Slurm, Singularity are not typical data center type tools people are familiar with in financial services. That's more from academia. But if you want to do state-of-the-art simulation, those are the kind of tools you're using. So what the IT vendors are being challenged to do is, can we build an infrastructure that can combine these academic tools with things like Docker, Kubernetes, things that the AI people use. And it is starting to come out. So a plug for Dell is they create an open source code called Omnia that allows you to integrate these environments together. Now, part of the ecosystem here is how do I develop my AI model? On the left-hand side here are very popular tools, Gartner's Magic Quadrant of the leading machine learning platforms. Now, on the right-hand side, what they decided to do was to build one Magic Quadrant just for the hyperscalers or the cloud vendors on their machine learning platforms, so that they could be in the upper right-hand quadrant. Because if you take Google, you take Microsoft Azure, take AWS, SageMaker, and you compare them against the on-prem tools, they land in the bottom right-hand quadrant. They're viewed as visionaries, but not leaders. So it's a nod that the on-prem tools are still kind of the better tools. Part of the ecosystem, and probably one of the most critical things, is the data platform. And as you build this for AI models, you need a way to ingest data, keep it there in its raw form, transform it into something that's usable, and then optimize it, put it on a platform where your users on the right can get quick access to that. This is probably 80% of building your AI application. Certainly building the model is important, but most of the data scientists I know spend 80% of the time trying to optimize this. Now, financial services is probably one of the leading industries in leveraging what's known as alternative data. So these are data types that people still aren't sure what the value is, but many firms out there believe that there is value. And if you want to leg up in, let's say, analyzing future activity of a company, its potential stock price, etc., people are using satellite imagery at night to see if the lights are on. You're getting some wild use cases out there. So some may say it's all speculative, but many are saying that there are some of these things do have merit there. And so the data is categorized as from very immature to very mature data. But it's a growing market, and not surprisingly, financial services is the leading industry in assessing this type of data and incorporating it into their models. Now, this is just a landscape I've put here for your reference. This is certainly not a complete list, but these are some of the more prolific industry vertical applications out there. So on the far left here, we have streaming type applications. So more and more people are taking real-time data. So in financial services, perhaps it's sentiment type data. And then the next use case here is to use augmented analytics and a central data store. Often it's a data warehouse. But there are new technologies here, augmented analytics. A vendor like ThoughtSpot is using Google type of analytics, speech recognition, and to perform their queries in the background. As you move toward using other data types, unstructured data types, video, audio, data types, people are building these data lakes, and there are a number of vendors or solutions there. And then finally, for machine learning, there are several tools out there to help you automate this. So kind of take a pause here. Here's the challenge here if you're in this industry and work on AI. On one hand, a lot of people are saying, I don't have the right kind of data. I need more data. And then on the other side, what we hear a lot of people saying is they can't handle it anymore. So it really kind of depends. It really kind of depends. I can't say equivocally that I believe this is the state of the nation. I hear both sides. What I am seeing now is that, dial it back about 5 years, everybody had a cloud strategy, still do, and many firms are just throwing everything in the cloud. Everything's got to go in the cloud. But I think today what we're seeing here is a more thoughtful approach, is where maybe the cloud isn't the one be-all, end-all platform, and maybe we don't want to put a 10 petabyte type of data application up there. And so people are stepping back, taking a more business approach and saying, okay, does it make sense? And one of the key criteria that they take a look at is, where does the data best reside? What kind of requirements should we be considering? I'm going to go a little quicker so I can end on time, but public cloud adoption should be no surprise that AWS, Azure, Google Cloud are the top three. What may surprise many, and this is something I predicted in a previous presentation I delivered with Jose, was that VMware Cloud is now the fourth most prominent cloud. And what people are building now are multi-cloud and AI, combining these two, I guess, pivotal technologies that are involved in many digital transformations. Now, going forward, I see very few firms saying everything will be on-prem. And I see also very few firms saying everything will be on one cloud vendor. What we're seeing is multiple clouds, and typically with on-prem as well. And so these are some of the benefits that people are citing from this approach. Access to data. So rather than consolidating it, just kind of keep the data where it is. Now, for the people starting off, access to GPUs, because GPUs are not as inexpensive as CPUs. So some people are going to the cloud there, but in the long run, if you're going to do heavy-duty training of models, it is much less expensive to train on-prem. So I would qualify the third point here, where people are saying hybrid cloud provides a better development platform. I think it gives you a better development environment if you have the option of having training data on-prem and having your trained model running in the cloud. This is for your reference. We don't have time to go through this, but I put this together to identify the key analytics offerings with advanced analytics, machine learning from AWS, Azure, and cloud. I put in what Dell offers, and then on the far right, what the open source. So many things to consider, and I can certainly tell you there's nobody that is the best in all of these. And so the multi-cloud AI, it does make sense, and try to leverage the best of all worlds for your environment. This is what I'm also seeing with a number of the firms here in trying to accelerate AI development, a model-driven approach here, focusing on the bottom here first, using platform as a service to lay out that environment. And this new technology, starting to see at many firms, is a data catalog. There are a few ones, Bloom is just one example. And so what it does is build a repository so a person coming into the environment, a self-service environment, to say, okay, what data is out there? Can I get access to it? That's what your data catalog provides. I'll say here in the time got left here, as you build these AI applications, consider these qualities of the data up front. Don't think about this at the end. And by the way, we've got to make this secure. These things have to be thought of ahead of time: privacy, ethics. How is this data going to be used before you build your model? And the approach to build a model, and one of my past lives, I was an enterprise architect. I still enjoy that world. And this is taken from TOGAF and modified for building AI. But it starts in having the vision, the strategy. The technology, fairly standard in trying to assess your current the state of possible, but as you build your roadmap, very important to cost justify this and to build kind of increments and get there. Don't go for the big bang. Build incremental deliverables. A plug here for a resource that I use often is the HPCEI Innovation Lab. Just outside of Austin, it has a cluster of AMD, Intel, and NVIDIA GPUs there. And so I've consumed 100 GPUs for this one customer to advance their research. So, and it's a resource I use to help data scientists at other firms optimize, their algorithms and better identify kind of what the right platform going forward is. And yes, usable by other customers as well. So the future does look promising. This is a survey that we hired Forrester's consultant to do. So more and more machine learning will be used, and anomaly detection, fraud detection, a big use case. The data as a service model, the use of data catalogs will get, again, more popular, and investments in improving the data lake. Okay. And here, my last slide here. So just to summarize some of the best practices that we see from successful firms who have implemented AI is nothing against the RPA and BPMs, but for AI to succeed, you have to have a data-driven culture. Treat data as an asset. I guess the concern I have now with some of the firms is while AI is taking off, the AIs are themselves becoming silent, and there's opportunity there to consolidate each of the data that they use. So probably a near-term thing that we're going to start seeing when AI gets much more prolific is to make it easier to make it as a shared resource, because everything's still kind of new for AI and the optimal infrastructure. Adopt an architectural approach, as I showed you before that slide, as an enterprise architect. Have a strategy, have a vision of what are the reasons, what are the business outcomes that you're driving with AI. And let it be known that each AI application is a unique journey unto itself. So that finishes the presentation part. Jose?
That's terrific, Bill. It's always a masterclass with you about artificial intelligence and the applications in really across multiple industries, and now, this focus on financial services today. I'm gonna ask you, unless you have something on the appendix you want to share. Yeah, I was going to ask you to stop showing the screen there, and I'm gonna jump in here on some questions and things that emerged from the audience. And Bill, the very first one has to do with the definition of AI. This is some in the audience have watched your presentations before, and they always appreciate it so much. And I want to get to some of the basics here. There seems that nowadays become trendy to call maybe more advanced modeling and data analytics artificial intelligence. And so where's the line? Where does advanced modeling and data analytics stop and true AI starts? Because it seems that the word's being overused and misused. So we thought we should ask an expert about this. Where does the definition of AI truly start?
So, good question. And what I have seen in some companies is, because there's kind of a new shininess to the word AI, people use it to cost justify their projects. The typical advanced analytics, BI, for instance, because it's not as let's say in the spotlight. Their concern is that it'll get overlooked. So unfortunately, I see that trend continuing. But what does make it truly AI? And so AI, the core thing is really the algorithms being used. So in most applications today, it does require a lot of data, so it's very data centric. And the algorithms it uses typically are these deep learning algorithms. And if it's not using that, it's probably just traditional advanced analytics, like using regression analysis to make a prediction. That is an example of a machine learning algorithm. Is it AI? No, but can it deliver business outcome? Certainly. And one question I ask a lot of people first is, do you really need AI? Do you really can this be done with conventional machine learning algorithms? And if it can, then let's do it, because we're going to get our business outcome. We're all heroes here. But if it's something where you're trying to simulate human behavior, decision making, that is beyond regression analysis. So examples of that: natural language processing. Can I interpret this document and find nuggets of insight there? That cannot be done by conventional traditional algorithms. You need a deep learning algorithm that recognizes text and its meaning. Other examples are vision-based. Can I detect, let's say, a driverless car? Those algorithms there are all deep learning AI-driven algorithms. So hopefully that gives you some idea, but I'm all for advanced analytics, and it's still got a great place, still drives a ton of value, and so there are problems that are uniquely built for AI, where AI does well.
That's excellent. The definition that you have with some, not just an algorithm, but a learning algorithm is a very good starting point. The other day I had a discussion with someone who says that if it's an algorithm, it's an AI. I was like, come on, Kyle. I used to develop chips for calculators, and we have algorithms to how to calculate a square root of a number. It does not make it artificial intelligence. It's just an algorithm. But so thank you for that clarification on deep learning and the kind of somewhat cognitive capabilities of an algorithm. That's what you talked about there, which is very helpful. What about there are a number of questions related to the development of AI, both on the software side, or deep learning side, but also on the hardware side. We are all hearing all these disruptions in the supply chain related to in the automotive industry with chips, and has that kind of spilled over into this more advanced chip manufacturing that's required for artificial intelligence applications?
Unfortunately, the supply chain challenge right now, I think, is universal. I, I'm trying to order a refrigerator, and it's taking 4, 5, 6 months now. So certainly it's impacted the technology industry. Certainly it has impacted GPU-based servers or large supercomputers. So technology vendors will be telling any customer interested in building this AI infrastructure is order early, because unfortunately it's taking that time. I see that going away. I'm hoping that this is just a kind of a short-term blip as we get more into normal operations. But yeah, we're still seeing it for probably the next few months.
Very well. Another question has to do with how to get started, and maybe how, there's a fear that people have, and these are technically capable people that understand the basics, but they're not sure about what AI platform to start with. Do you have, and I know this is very tricky because of your position, but to the extent that you can talk about this, do you have any recommendations for people who wanted to get started with artificial intelligence on the technical side but they're not sure about what, about making an investment in an AI platform, if you will, but maybe there's some open source items out there. You may have even mentioned that some of them during your presentation, but the question is, if you want to get started on the technical side with an AI platform, are there open source alternatives that you can start with, or you're better off starting with a kind of a beginner's, commercial AI platform and system? Do you have any thoughts on that?
Yeah, a difficult answer that's universal. So let me kind of give a spectrum of possibilities here, depending on the person's background. So myself, I hate coding. But I'm in computers all the lot. I deal with algorithms all a lot, but I don't like it. I like the output. I like to see what things can do. So, but I know many people who love to code. So if you're coding, if you come from that world, if you're that technical enough, learn Python or R. That's probably the most popular too. There's some great open source things like, I would probably suggest Spark, and get on NVIDIA's developer site. It's free to sign on. They've got lots of webinars. But if you're not coming from the heavy technical and you're still interested in getting AI, I would suggest get to understand data analytics, because AI is just part of the continuum of data analytics. And I believe that in the not too distant future, and even today, there are applications out there where you don't need to code Python or R. It does it for you. It asks you, where is the data? Let's train it with this model. What do you think are the characteristics that drive a better person to pick for a loan? Is it salary? Is it where they work? Is it all these? So it's really understanding data analytics. I think that is the core thing in understanding AI. And and I believe that there's going to be more and more what I would call a citizen data scientist. People understand how data can be used, but you're not going to code. That's not going to drive a lot of value. But again, if you like that, my hat's off to you. There's certainly a wealth of open source things to go out there. Of the vendors, I would probably say start with Google. Google's got a lot of great work that they've put out there as open source. They've done a lot of innovative things. For breadth of data type of technologies, certainly Amazon has quite a few as well. And if you're a Microsoft-oriented person, look to the Azure-based technologies. But open source will work on all those cloud vendors. Again, if you're interested more from the data analytics side, spend time, and you can, there are open source applications out there, open source AI frameworks. You might get a little code, do a little code, but it's kind of a pseudo coding, like a fourth GL. But understand data, understand criteria, what makes good decision making. I think that is more important than the actual technical bits and bytes.
My goodness, what great insight and input. I have people saying excellent presentation. Thank you so much for that input. Very valuable. We are actually right on time here. I wanna thank you, Bill, for always presenting incredible data, incredible benchmarks, insights, and summarized information that's incredibly useful for all of us. Thank you so much for taking the time and sharing that wisdom with our global audience today.
Thanks, Jose. Thanks, everybody. Have a great conference.
Ladies and gentlemen, that's Bill Wong, artificial intelligence and data analytics leader for Dell Technologies. Always a masterclass on the practical approaches to artificial intelligence, in this case in financial services. So very grateful for that. We're going to be taking a break now, and at the top of the hour, we're going to come back with Ashish Nigan, who is the Chief Information Officer and Chief Technology Officer for PFS. And he's already given us a preview right there. Well, I'll see you at the top of the hour, Ashish, and with our global audience. And I will close the session now and open back up to the audience at the top of the hour. Thank you, everyone.